Okay, so number 3 says use the fundamental identities to simplify the expression. We don't need to use that. So we have basically 6 cosine x, but we're going to say cosine beta because it's a variable, and tangent of beta. And my goal is to simplify. First step, what do I do? Yep, so everything changing in terms of cosine and sine. This is going to be cosine of beta over 1. This is going to be 6 over 1. It's all multiplied and glued together. And tangent is what? Sine over cosine. So sine of beta over cosine of beta. It's all multiplication, so what can you do immediately? Cancel forms of 1, and you're left with 6 sine of beta. Just make sure you put beta, not theta. Make sure you don't put x. With Weber sign, you got to make sure that your variables are in check. Cool. And if you put sine of theta on your test, I'm going to say that you misspelled beta, and I'll give you full credit. But just be a little bit more attention to detail, okay? All right.
Can we go up one just really quick to number 2? I just have a quick question.
Yep.
See that like where it says cosecant squared?
Right on C?
Yes, sir.
Yeah.
So how, like, I got cosecant squared equals 1 plus the cotangent squared.
How could we get that?
Yeah, like.
Here we go. Guys,
So that was the one I couldn't figure
I've told you, those of you wanting to go to calc, I said if you can memorize this and know how to manipulate it, you're good to go. You with me? So if I want to create cosecant squared, first I need to know that cosecant squared is 1 over sine squared. Do you agree? So 1 over sine squared. I can create that piece here. Do you see it? I can create that piece if I divide all 3 terms by what? Sine squared. You see what I'm doing? So here will be sine squared, we'll say x, sine squared x, and sine squared x.
And then they just cancel out, right?
Yeah, I've created this right here, which is equivalent to cosecant squared. And what is cosecant squared going to equal? All of this, which is cotangent squared plus 1. So that would be the answer. Knowing how to manipulate just that one equation, whether you're subtracting or multiplying or dividing, you can create a lot of identities just from that one.